This question asks whether an AM signal can be demodulated by squaring it. So this kind of device is called a square law device, where the input is squared at the output. So is it possible to take an AM signal, square it, and then pass it through a low pass filter to remove high frequency terms to recover the original signal? So is that possible? It is, and the question is asking to show how that's possible mathematically. So let's start with a representation of an AM signal. So an AM signal is a double sideband large carrier signal. So essentially that means that at the input you have something like that, where you have a high frequency carrier multiplied by a DC term plus your message. In this case it's a single tone message with your modulation index M. So that's your input to this demodulator. The output of the square law device is that squared. So if we square that, that's the output. So that means we'd square both of these terms. And then you have a cosine squared, and you have this binomial that's squared. And when you do that, you end up with AC squared. Now cosine squared will give you half 1 plus cosine twice the angle. And when you square that, you get that squared, you get this times 2, and you get the second term squared. And if you open out the brackets and you multiply that through, you'll see that you have, if you multiply the constants, never mind this, that's just a scale factor. If you multiply the constants, you'll get a DC term. So that's your DC term there. And if you multiply your 1 times the cosine omega m, that's actually your message. That's what you're looking for. Okay, so that's your message term. And then finally, when you multiply your cosine times cosine, you're going to end up with high frequency terms. And those are the three things that come out of your square law device. Now, your low pass filter will remove the high frequency terms. The DC term can be removed by a capacitor, so your final y of t will just be your message. So you can say y of t will be some constant times cosine omega m t, which is your message. So this will high frequency, sorry, let me write this down. So high frequency will be removed by the low pass filter. And the DC term isn't a problem, that can be removed by a capacitor. So we've shown that it is possible to recover our message here by passing it through a square law device. So it's not the kind of coherent demodulator we're used to, and it's not an envelope detector, but a square law device can nevertheless be used to demodulate AM. So it is possible.